All right, now that we've done some multiplying and dividing rational expressions, let's do some adding and subtracting. Similar to the numbers, right? If I have like 2/3 plus 1/6, I got to get a common denominator before I can add those, right? Which would be, in this case, 6. So I'd have 4/6 plus 1/6, which should be 4 plus 1, 5, 6, right? So same thing with rational expressions. I got to make sure that they have a common denominator. Well, this one does. 13 over x plus 6 over x. So 13 plus 6 all over that common denominator of x. So we just end up with 19 over x. So we just want to make sure we have a common denominator on these. So what you're going to do is I would go ahead and you may have to factor it, right, to see if you do. Like this one, we've got a y plus 2 and a y plus 3. And over here it looks like, okay, they do. It's a y plus 2 and a y plus 3. So they have a common denominator. I'm happy about that. It's y squared plus 5y plus 6, or y plus 2y plus 3. So we can go ahead and put it all over y plus 2, y plus 3. So I've got y squared plus 4y, that numerator, minus the y squared minus 8. Now I'm going to have to distribute that. Y squared, so I've got a 4y plus 8. Well, 4y and 4y plus 8 would factor out a 4, and I'd have y plus 2. And notice my y plus 2's cancel. So I'm just left with 4 over y plus 3 here. Now here, the second one is saying, what if we were adding these two up? In other words, what's the least common denominator? Well, what you want to do, if you're not sure, is you go ahead and factor it out, right? Like 18 is 9 and 2. Or 3 and 3 and 2, and then you got x, 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 right? So it's the least common denominator, least common multiple, right? We're looking for what's the least common multiple. For the 66x, so I have 11 and 6, 11 and 6. Of course, the 6 is 3 and 2, and then the x, right? So the least common denominator would be, in other words, the least common multiple. See how I have an 11 there? I got to include an 11. I have the most of whatever I have. So see how I have 2 3s on the top and 1 3 on the bottom? So I have to have at least 2 3s. And then, okay, so I take the most of whatever I have. I have 2 3s, right? And then the 2. I have one, they each have 1, so I just need 1. And then I have 3 x's on the top, 1 on the bottom, so I got to have at least 3 x's. So then I just go ahead and multiply out 11 times 3 times 3 times 2, which is 198 x to the third. That would be my least common denominator if I was adding these two. I would want to have 198 x to the third be my least common denominator. Let's do some more here. X minus 8 and x squared minus 64. Well, that factors into x minus 8. This one factors into x minus 8, x plus 8. All right, so the least common denominator would be, I'd have to have an x minus 8, and I'd have to have an x plus 8 before I did that problem. What would our least common denominator of these two be? In fact, let's just act like that we're going to go ahead and add these. So x squared minus 16 is x minus 4x plus 4. The next one, I would take an x out. So if I really was adding these, notice they both have an x minus 4. So I'm okay there. The one on the right has an x. See the x? The one on the left does not. So I'm going to give it an x on the top and on the bottom. And you see how the one on the left has an x plus 4, but the one on the right does not? So I'm going to have to give it an x plus 4. And so that's how I would do this. 8x plus 3 times x plus 4 all over this common denominator. Now, it's really only asking for the least common denominator, so we're not going to finish it. But that's how I'm thinking about these. All right, that's how I'm finding the least common denominator. I'm getting the least common multiple. Now, same thing for this one. If I was adding these up, I'd factor that. I'd have x minus 9, x plus 2. Now I'd factor that 2x squared plus 3x minus 2, which I did there, 2x minus 1, x plus 2, sorry, I didn't record that. And then I'd compare them. I say, oh, they both have an x plus 2 common denominator, perfect. The one on the right has a 2x minus 1, the one on the left does not, so I'd have to give it a 2x minus 1 top and bottom. And finally, the one on the left has an x minus 9, the one on the right does not, so I'd give it an x minus 9 top and bottom. So again, that's our least common denominator right there. Now we have it 2x minus 1, x minus 9, x plus 2. Okay, here's some U-try problems. We'll go ahead and imagine that we're actually adding or subtracting these, and we got to get a least common denominator. The one on the left has an x minus 9, so the one on the right needs to have an x minus 9, so I give it top and bottom. The one on the right has an x plus 4. The one on the left does not, so I would have to give it an x plus 4. Now they have a least common denominator, x plus 4 times x minus 9. Same thing for this one here. If we were adding these up, the one on the right has a y, the one on the left does not, so I'd have to give it a y and a y. Notice the one on the left has a 4, the one on the right does not. I'd have to give it a 4. And finally, the one on the left has a y plus 9, the one on the right does not. I'd have to give it a y plus 9 top and bottom. And there's our least common denominator, would be the 4y, y plus 9 if I were to add these up. And finally, our last one, to find our least common denominator before we actually add them. I would go ahead and factor this. Again, we're going to imagine that we are adding these up. So this would have to be a 2x and an x, 4 and a 1, so that would be a plus and a minus. Okay, they both have an x plus 4, so I'm happy about that. The one on the right has a 2x minus 1. I need to give the one on the left a 2x minus 1. And then the one on the left has an x minus 5. This one does not. And there's our least common denominator. So our least common denominator is 2x minus 1, x minus 5, x plus 4. Right, so let's go ahead and we'll add them now. Let's get a common denominator and actually do the addition. Notice the one on the right has 2x's, x squared. So I'm going to have to give this one another x. If I give it to the bottom, I got to give it at the top, because x over x is 1. I can't change this, right? I'm just multiplying it by 1. So we got 10x over x squared plus 3 over x squared. So we got 10x plus 3 all over this common denominator, and we're stuck right there. This next one, we've got a subtraction. So we got 4 over x plus 7 minus 2 over x minus 7. So again, we've got to get a common denominator. The one on the left has an x plus 7. This one does not. I got to give it an x plus 7. The one on the right has that x minus 7. This one does not. So I'm going to have to give it an x minus 7. So I got 4 x minus 7 minus 2 x plus 7. This is now all over our common denominator of x minus 7, x plus 7. And we can go ahead and start cleaning this thing up. We've got 4x minus 28 minus 2x minus 14 all over our common denominator. 4x minus 2x, I got 2x, negative 28 minus 14. And I could keep going. I could take a 2 out, but it looks like I'm still stuck right there. Nothing cancels at this point. So all done with that one. Go ahead and you could make this a U-try problem if you want to pause the video. It'd be a good one. Notice the one on the right has a 3y. The one on the left does not. So I'm going to have to give it a 3y top and bottom. The one on the left has a y plus 4. This one does not on the right. But now we have our common denominator of 5 times 3y, so 15y, plus 2y plus 4, so 2y plus 8. This is all over our common denominator of 3y, y plus 4. So we have like terms there. I want to combine any like terms. 17y plus 8 over 3y, y plus 4. And we're all done adding those and simplifying. Go ahead and write this out. This is minus 1. Of course, it's over 1. So I just need an x plus 12 over here. So we got x minus an x plus 12. This is now over our common denominator of x plus 12. And now distribute. Notice our x's cancel. So we get negative 12 over x plus 12. Similarly, on this next one here, we have 4x, factor that x minus 7, x plus 7. Over here, I've just got an x minus 7, so I'm missing an x plus 7. And then now we've got that common denominator. I'm going to distribute that all over that common denominator. And then combine like terms, so we've got x squared plus 11x, which I can take an x out, but nothing cancels, so we're just all done here. I'll go ahead and pause the video and make these U-try problem like. This one will factor into x minus 2, x minus 4. Notice they both have an x minus 2 on the bottom, but this one's missing an x minus 4, so we'll give it an x minus 4. So now we got 7x plus 5 minus 7 times x minus 4 all over this common denominator. I just got to distribute that minus 7x. Notice 7x minus 7x is gone, so we just got 28 plus 5. I've got 33 over x minus 2 and x minus 4 there. Again, feel free to pause the video on this last one here as well. Factor that and see what a common denominator is. Two of these x plus 7s. So they both have an x plus 7, but the one on the right has 2x plus 7. So I got to give this one another x plus 7. And then notice this one over here has an x minus 7. This one does not, so I'm going to have to give it an x minus 7. So we'll end up with 3x plus 7 plus the 2x minus 7 over x minus 7 and 2 of these x plus 7s. So we got 3x plus 21 plus 2x minus 14. This is all over x minus 7, x plus 7 quantity squared. 3x and 2x, I got a 5x. 21 minus 14 is a plus 7. So we got 5x plus 7 over x minus 7, x plus 7 quantity squared. That's our final answer, and that's how we add and subtract rational expressions by getting a common denominator. Thanks so much for taking notes. See you next time.